Good afternoon, everyone. My name is Jorge Escurra. I am the professor of the GIS in Water Resource class. The reason why I'm doing this video is mainly because currently I'm overseas, and the purpose of this video is give you an introduction of the GIS class, give you an introduction what is the GIS class is about, and mainly also take you through the syllabus of the course. It's very important that you know that that the GIS course, or what is GIS, and also give you the basic things during this video. One important point is that I will be coming on January 19. So if you have some questions or you don't understand, please feel free to discuss further with me when I am back there on January 19. Another important point is that you will see that the video stops sometimes when I am talking, but my voice continue in the video. So yes, that's okay. I have the computer is almost full, so it's slowing down the video, so that's the reason why it stopped. But again, it's going to recuperate again, and especially it's going to return again my image, but and also the voice continues, so that's important. Well, let me give you a very brief introduction about the GIS. What is GIS? GIS is a Geographic Information System. GIS, or ArcGIS, is a software. The software is developed by ESRI, E-S-R-I, the ESRI, which is a private company. The cost of the software is close to $5,000 to $6,000. The good thing is that you can get a 30 days free trial. You can download a 30 days free trial. I will suggest you download the free trial right now. Download it like more or less when you start to develop your project term. So I will let you know where you're going to download it, because again it's only 30 days. I suggest you that you use it mainly for your project. When you are doing your project course, the GIS project, so you will be able to do this type of project at home or in other places. Okay, so another important point is, I think that you have received from Dr. Tolesa the PowerPoint presentation for lecture 1, and also you have received the syllabus. So you have two things: the lecture, the PowerPoint presentation for lecture 1, and the syllabus. Okay, so now please all of you open your lecture, your PowerPoint presentation for lecture number 1. In that presentation, if you open the first slide, you will see a map. That is a map of Afghanistan, and it shows the average annual global horizontal radiation in kilowatts per square kilometers. As you can see here, as you can see in the map, there are different colors, no, green, red. So that shows you for each color there is a specific number which is linked with the annual global horizontal radiation. All this map you can do it using ArcGIS. So the reason why I put that map in the first slide is to show you what you can produce with ArcGIS. Another important aspect is that you can see from that map, you can see the scale at the bottom, you can see a legend, you can see the title, and you can see some icons that represent the name of the institution. So another important reason why this course is going to be very interesting for you is because also help you to open a new business in your career, because there is a lot of GIS, Geographic Information System specialists, that are needed to work with different sectors. As a GIS specialist, you can work with the law enforcement, you can work for agriculture, you can work for water sector, you can work for transportation, you can work for the economic department, etc., etc. So open different possibilities of work, not only again with the water resource management sector, you can also work with other sectors as well. So if you handle this software and you really like it using this software, and you get good in this software, I think that will help you to open a new business market for you and your career. Okay, now let's move everyone to slide number 2. Slide number 2, if you can see there, is talk a little bit about me, so you know who I am, you know what is my background, and help you more or less to understand help you to understand me more or less how I can help you, and how my grad can help you in the preparation for your career. I have a bachelor degree in agricultural engineering from Agraria La Molina University from Lima, Peru. I have a master and a PhD in irrigation engineering from Utah State University. In 2002, I joined the Colorado State as a postdoctorate. Then I worked at the World Bank since 2009 until 2014, and currently I'm working for a company called RTI International. So currently I'm working for a company called RTI International. Another important aspect that you need to know is that there are 5. Let's move to slide number 3. Sorry, I forgot to let you know that we are now moving to slide number 3 of the presentation lecture number 1. If you see, there are 5 basic core elements that I would like to explain you. 5 basic core elements. The 5 basic core elements during the course are lectures, readings, third projects, class interaction, and examination. Okay, during the course we are going to have, if you see also your syllabus, all of you have your syllabus with you. During the course we're going to have 2 main days that we're going to give the course: Tuesdays and Thursdays. On Tuesday we're going to have the theoretical part of the class, and on Thursday we're going to have the practical use of the class. In the theoretical, what we're going to do is we're going to have presentations like this one, so we're going to go up through the theory of using GIS. And on Thursday we're going to have the practical. We're going to use the computers, and we're going to have I will provide you handouts, and you will be able to go through the handouts, and you will produce a product. You will produce a map, or you will produce any product that is expected from the handout using your computer. So in this class you will have the theoretical knowledge and you will have the practical knowledge. But to highlight is that we're going to have third projects. We're going to have a third project during this class. The third project will be done with 2 people or one person. I will talk more about the third project when I am there. I will be there on January 19. But the third project involves two main aspects: the oral presentation and a writing report. Then also we are going to have another thing that also I will evaluate is the class interaction, discussions, questions that you can ask. In this part I would like to highlight the importance of assistance. It's very important that you come to all the classes during the week, because during the week we're going to have one homework, and we're going to have the homeworks are coming from the theoretical part and from the practical part. If you miss one or two of these labs, will be very hard for you to in a row, or will be hard for you to catch up and understand, because each lab is built in basis of the previous lab. So the lab that I'm going to give next week will be based on the lab that I will give this week. In this case, because I am not be there, I will the next lab I will repeat a little bit about this lab, but the following labs will build in basis of the labs before. So if you miss the labs, what I will say, for X or Y reason you have to miss, what I will suggest you is come to me. I will try to give you update, but also work with the other students, so they can provide you some guidance. The other students who came for that lab, they can provide you some guidance. So it's very important that all the class work as a team. Now we're going to leave the presentations and let's go everybody to the syllabus. All of you have your syllabus. In your syllabus, go to the third page. You have the first page where it says University of District of Columbia. You go to the second page and then go to the third page. In the third page, go to the bottom, more close to the bottom. It says grading criteria, 100% grading scale. So the way how will be evaluated will be we're going to have 8 when we're talking about 90% and above, B 80 to 99%, C to 70 to 79%, and F below 70%. The global assignments will consist of the writing and oral reports and the examination. It's important to highlight that the lab exercise and homework is 30%. The lab exercise and homework is 30%. These homework, that you are coming to the lab and also giving the homework every week will give you a 30%. Then the GSTER project is another 30%. So with both of them, you already have 60%. You already have more than 50% of the total grade. Now the examinations are the midterm exam with 20% and the final examination with 20%. What I want to let you know is, for instance, if you don't come to the classes, or if you come to all the classes, or try to come to most of the lab exercise, I'm sure that you will have a good grades in the 30%, and also I'm sure that you will do a good GIS project, a UGS 10 project. So this is another 30%. So coming to the class, you already have almost 60%. So to pass the class, you will need a good score for the midterm exam or for the final exam. However, if you don't come to class, you will have a problem because you will not have good grades in the homework, because some of the homework you will not be able to turn in. Maybe you will not go well with the GIS project, and the problem is that you will have to count in the final examination and the midterm exam to pass the class. So I want to highlight the importance of assistance in this class. Okay, so now what I also want to show you, if you go to page number 6 of the syllabus, where it says class schedule, I will show you in the class schedule what is going to tell you is all the topics that we're going to cover, and when that's supposed to be the big term exams, the date of the big term start at the final exam. Also, the presentation, the study presentation of the term is expected to be on April 21st, and on April 19, I will bring a guest speaker. Right now, I have a guest speaker from the World Bank who is going to come and give you a presentation about why GIS, Geographic Information System, is very important for development. So I have it scheduled, the guest speaker, from April 19. Now let's minimize that syllabus and let's continue with the presentation, with the PowerPoint presentation lecture number 1. Now, when we're talking about lecture number 1, what I want to let you know, let's go everyone to slide number 4. Slide number 4, we're going to start to talk about enter into the introduction. Today I will talk about two main topics. One is the geospatial database, and the other one is the hydraulic features. The geospatial database. The geospatial database, as an introduction, what it's going to give you is the importance of understanding what is geospatial. Geospatial, which is the main concept of the ArcGIS. And then we're going to talk about hydrologic features. Hydrologic features come from hydrology, which is the study of the cycle of the water through the basin. So ArcGIS also, or the GIS, has different features that allow you to quantify the hydrologic impact in the basin. So let's move now to slide number 5. Before entering into ArcGIS, into the geographic geospatial database, I will give you a brief explanation about how these geographic database models differentiate from another type of model. There are 5 types of model. We have the conceptual model, the mathematical model, the data model, the geographic data model. The conceptual model, again, if you see that image is stopping, no worries. I think that you still continue listening to me, so no problem. Again, I apologize, my computer is almost full. That's the reason why the video stopped. The conceptual model, what is a conceptual model? Let me give you an example of a conceptual model. A conceptual model is, for instance, when you are having one river and you're having another river, and both rivers combine and or join, and then appear only one river going down. So if we know that one of the rivers is bringing 3 cubic meters per second of flow and the other river is bringing 2 cubic meters seconds for flow, how we are going to calculate the flow that is coming from the diverge, from the join of these two rivers? Very simple. We're going to use a concept model. We're going to just add 3 plus 2, and this will be 5. So the flow that is coming after joining these two rivers is going to be 5 cubic meters per second. Very conceptual, no? Just add one flow from the other river to the other river, and then you have the total river. So that's conceptual. So it's a subject and allow you thinking about it. Now, when we are talking about mathematical model, we are entering more into specific equations. For instance, I don't know if you have heard about Manning equation. The Manning equation is an equation that allows you to quantify the amount of flow going through an open canal. The parameters of a Manning equations are slope, longitudinal slope, roughness, which is the material of the roughness is related with the material of the canal, how the canal has been built. For instance, concrete canals will have different roughness than earthen canals. And the other important aspect is area of the canal. If the canal is a trapezoidal, we have a different cross-section area than if it's a rectangular canal. So all these parameters are combined and are part of the Manning equation. In basis of this Manning equation, we're going to be able to calculate the flow going through the canal. Another important aspect is the data model. The data model is a conceptual model which is related with which is represented with a data structure. For instance, Excel tables. Imagine that you are getting you have a flow gauge station, a gauge station that is located in a specific point of the river. As you know, the flow gauge station is going to constantly measure, could be hourly or daily, the flows coming through the river. So you will get all this data from the gauge or flow station in an Excel file. So you will have hourly values of flows in Excel file. So if you want to calculate monthly, you start to calculate the average, the daily, and then you start to calculate the average for the monthly. So using a table, Excel table, you will be able to calculate flows in the river. No? You are using a data structure. So that's example of data model. Another important aspect that also we are to consider is the geographic data model. The geographic data model is when you are using the geographic information system, and also you can use another type of model. In this case, for instance, the GIS have already hydrological features that allow you to do calculations. One of them is called R-Hydro. So through this hydrological feature, you can calculate the flow in a specific basin. Another important aspect is geographic data model is not only specifically with GIS, also is related with other software such as map windows. If you Google map windows, MAPWINDOW, that will allow you to calculate or to know that this is a free software. It's like GIS, but this is a free software. This free software can be downloaded for free from the internet, but it's not going to be as complete as the GIS, though. But helps have several of the important features. Again, also open source. What that means is also you can do some coding and contribute to do some function for this software. Okay, so with this, what I'm trying to explain is that different between the geographic data models and other type of models that we have here. Now we are in slide number 4. Slide number 4 talk about data models. And also, if you see in slide number 6, if you see, we already just discussed about slide number 5. So now in slide number 6 from the lecture number 1, we're going to see these different data models. So as I explained before, if we have all these geographic data models, the geographic data models, what will allow you is to bring different type of layers together, and that is what the GIS does. So bring you all these different type of layers together, such as stream, hydrographic points, drainage area, hydrography, channels, surface terrain, rainfall response, and digital or topography, or known as a DM, digital elevation model, or topography maps. So after you're having all these different figures together, what is going to allow you is you will be able to do different calculations. You will be able to understand different specific points. For instance, you will be able to calculate the flows in the river. You also will be able to calculate what are the areas prone to floods problems. Also, you will be able to calculate, for instance, some areas that will have more impact due to increment of precipitation and temperature related with climate change. You also will be able to analyze, for instance, if you have a dam, if you decided to build a dam, how the dam will going to impact in the entire water cycle, is really going to help, is really going to increase, how much sediment could be stopped in the dam, and so on. So all these things will be able to be developed using the geographic information system. Again, the geographic information system allows you to put all these inventory of data layers all together and realize and develop different calculations using different functions, including the R-hydro function, which is going to allow you to do delineation and calculation of flows. Now let's move to slide number 7. Slide number 7. What slide number 7 is going to show you is what are the main principles to develop all these images in using the geographic information system. There are two main principles, or two main small units that could be used to do this geographic information system. First is the vector format. The vector format have three, or how to develop a vector format is defined by three small three basic structures. The first is the point. So you have a point, which have a coordinate x and y. Then you have a line, which is a sequence of different points, several points, and then you have a polygon. A polygon is a set of lines which is closed, a closed set of lines. So the vector map or vectors will be consist of different points, lines, and polygons. If you everything is in basis of the principle of the point. For instance, a sequence of points will give you a line. A sequence of closed lines will give you a polygon. So those are the main part of the structure of the vector format. And then again, what I'm trying to do through this video is giving you the basics. We are going to talk more and give you more practical explanation when I am back on the class on January 19. The other important aspect of if we move to slide number 8, is going to show you what or how this vector works now. So if you see slide number 8, you will see a map that have three different figures. The three figures represent the Eastern Nile River Basin, which is between the countries of Sudan, North Sudan, South Sudan, Ethiopia, and Egypt. And what is showing you there, is those are maps that represent precipitation. If you see different colors, the different colors represent the different amount of precipitation. It's important to highlight that all these maps are, if you see there, are vectors, have a vector format. And if you want to, I will ask you this question: what type of vector format, what specific structure of vector format do you think that these figures are using? Well, the structure that they are using are polygons. If you see close to that, those are small subbasins within the big basin, so those are polygons. And each of the basins have a value of precipitation. So this is example how polygons are used within a vector format. So that's a map, that's a vector format. It's how you will be represented in ArcGIS. Now, if we add to this map, for instance, if we add a point, where we are trying to indicate, a position XY, where we are trying to indicate that there is a flow gauge station, or where there is a dam, or where there is a hydropower structure, we are bringing point to the equation. So if you see in this map, you will see a point, and then if you add the drainage, you add the rivers, which are lines, you will have the three type of vectors, the three structure of vectors. Point, which is these dams, location of dams or flow gauge. Then you will have the lines, because you will have the rivers, and then you will have the polygons, which are the subbasins. So what I mean is, this is a representation only by polygon, but I am giving you an idea that you can also work with the other two structures together: points, lines, and polygons. And again, these represent a vector format. Now we're going to move to slide number 9. In slide number 9, it gives you another interesting figure. What happened is, my question is, you see a map there, okay? You see the different teams, which are the different layers to the left-hand side, but also you see a red map. That map is the map of the South Asia region. South Asia region, and which is the South Asia region, the small or the red areas or the red polygons are basins within the South Asia region. Those are basins. So the South Asia region consists of these countries: India, Bangladesh, Nepal, Pakistan, Afghanistan, and also Sri Lanka. So as you can see there, what is happening in that slide is you are having different information related with the different subbasins within the big South Asia region. Now my question is, what do you think this map is? Is a vector? And if it's a vector, what type of structure are using this vector? Well, this is a vector, you're right, it's a vector map, and the structure that is used are polygons. All the subbasins, all the basins within the South Asia region are polygons. So because there are lines, close lines, a sequence of lines that are close, so those are polygons. There are no points. Well, now we are going to move to slide number 10. Slide number 10, what is going to give you, that you can see, is that the map. When you see this map, what you're going to see is that this figure is linked with the attribute table. The attribute table have information related with, for instance, for each of these polygons, for instance, have information related with area, has information related with the type of shape. As you see, it said polygon, the name. You can also add information related with the irrigated area, the number of flow stations. So what I want to explain here is that all the figures are linked with a database, a table that have a lot of information. So everything is combined together. So ArcGIS or GIS is a software that allows you to link or to join figures with information that could be numerical or could be alphabetical information. Now, if we move to slide number 11, in slide number 11, what I want to show you is I say that there are two main principles, for GIS. We talk about vector, but now we're going to talk about rasters. Rasters are, the difference between vector and raster is that raster are vectors represented through a grid, so a grid cell. For instance, if we are talking about a point, the raster will be one grid. If we are talking about a line, the raster will be several grids. If we are talking about a polygon, the raster will be a lot of grids together, within the shape of the polygon. So the difference is that rasters are vectors represented through a grid cell. And each grid cell have a value. Okay, so those are the two main principles that I would like that you know. The main principles related with ArcGIS are vectors, that to have all the figures are vectors and rasters, and both of them are linked to information, to a numerical information or alphabetic information through the attribute tables. Now let's move to slide number 12. Slide number 12, if you see the map there, that represents is the topography, is the map elevation map. If you see the elevation map, you can see that here you cannot see very well the elevation, but if you're going down, you start to see more accurate what are the change of elevation. So these ones are the different size of the grid cells. Those are rasters and different size of the grid cell. If you see 90 meters, for instance, go until 1 meter. The size grid go from 90 meters to 1 meters. If you see, it's the same as a picture. If you have a picture with a different pixel size, you will have at the end better pictures will have those that have smaller pixels, so you will be able to have better resolution, so you will be able to see very well. So it's the same with rasters. Raster with the size of the grid cells larger will not be too accurate as raster with the grid set smaller, such as 1 meter. So this figure gives you idea about the accuracy and also the importance of the size of the grid sets when we're using rasters. Now, if we move to slide number 13, slide number 13 is a very interesting slide. Why is slide 13 very interesting? Because this slide combines what we have learned so far. We have, for instance, digital elevation models. Digital elevation model is topography, is mainly the same as the map before. Is mainly show you the elevation that you have through an area. For instance, if you have a mountains, that pixel value, that grid cell size will have the altitude of the mountain. And if you're having a hole, or if you're having a pothole, or you're having a depression, a topographic depression, that grid size that go into this grid size that go into this station will allow you to quantify the elevation. So those are the digital elevation models. If we bring together rasters, watersheds, streams, and water bodies, if we put all of them together, we're talking about raster and vector, we're going to be able to have a very interesting map, and we're going to be able to understand the importance of rasters and vectors through this map, combining all of them together. Now let's move to the last slide, slide number 14. And slide 14, what is going to show you, slide 14 is going to show you what happened when we put all the raster and vector together. If you can see here, you have the digital elevation model of a basin, you have the lines that are the polygon, you have the other area that is the lake, which is also a polygon, and then you have different sub-basins, which is also a polygon. So putting together polygons, putting together lines, putting together rasters, and putting together, we can add, for instance, a dam, a location of a dam, a point there. You will be able to have all this together, all the maps that are needed and are used for ArcGIS. Again, I will explain in detail when I come next week, but this gives you the takeaway from this presentation are two things. First of all, is that the main principles of figures in ArcGIS are rasters and vectors. Then the other is that raster and raster are linked to attribute tables that have alphabetic and numerical data. And the other thing that I would like that you understand is that vectors could be polygons, could be lines, or could be points. And rasters could be the same, but everything represented through a grid size. And finally, grid size are very important for the accuracy of the information.